everyone, this is Bigger Box. I'm Isabella. This episode is still filmed in a closed venue, but the task has changed to active safety. 9 vehicles, 10 major scenarios. Where are the limits of the active safety system of this vehicle in various dynamic and static scenarios? At the beginning of the program, we will first show the performance of each vehicle in various scenarios during the test. We tested a total of 10 projects, including nighttime accident vehicles, scenario of pedestrian and non-motorized vehicle crossing, obstacles such as lateral water barriers and cardboard box, and even wild animals. And let's take a look together. First, there is a scene of stationary rear of the vehicle during the day. We place a stationary dummy vehicle in the middle of the lane to simulate the situation of broken down vehicle on the road. Some drivers make emergency stop on the highway without setting up a warning triangle. If the following vehicle is not vigilant and rushes forward at a speed of 120 km/h, the consequences will be quite tragic. First, look at the results. As an A/B project that is master test for automakers and relatively simple, these 9 models can not only handle it, but also have quite high speed limit. The Luxy R7 and Voya Free Plus equipped with Huawei Qiankun at its full has steadily achieved a full stop at 130 km/h. Xiaomi Voya 7, BYD Han L, and Zeekr 007 GT also performed equally well, capable of braking to a stop at 130 km/h. And all can detect obstacles early and decelerate. Xpeng has excellent timing control, and distance from the target object at each stop is very stable. When traveling at a speed of 110 km/h, the system can still respond and trigger AEB, but the braking force is insufficient, ultimately resulting in a minor collision. The AutoLab SCC, also a vision-based solution, performed slightly better than Xpeng, achieving a full stop at 110 km/h during testing. IMLS6 early detected the target ahead and started early warning, but the timing of braking was too late, ultimately only achieved a stop at 80 km/h. The problem of Wave Blue Mountain and IM are similar. They detected the target early and issued a warning, but the braking timing was too late, ultimately only achieving a stop at 80 km/h. The nighttime accident vehicle simulated a vehicle that has irregularly stopped in a lane due to the traffic accident. The scenario we set up is diagonal parking, which makes the recognition a bit more difficult. And once recognition fails, the consequences of the high-speed collision are self-evident. Just to clarify in advance, due to the change of our venue, there might be a slight difference in the lighting. Therefore, we will not make a strong comparison, and the results are for reference only. The first step of the test seat is the closed road section with the street light and low beams highlights on, and Zeekr, Xiaomi, Voya, and Onvo were tested in this environment. The results are shown in the figure below. Both Voya and Xiaomi trigger AEB to brake and stop at 130 km/h, and SR interface rendered the model of the accident vehicle very early, with the function being very stable. And Zeekr can come to a stable stop at 120 km/h. During the test at a speed of 130 km/h, the braking force was insufficient, resulting in a collision. The AutoLab SCC, as a vehicle model for the key visual solution, can trigger AEB obstacle avoidance at 110 km/h. And also has warning and braking at 120 km/h, and basically starting to decelerate just when the accident vehicle model is rendered on the SR interface. However, due to late direction and insufficient braking, a collision still occurred. other 5 vehicles were tested under the light source we set up and with a vehicle low beam headlight on. The results are shown in the figure. The Luxy R7 can still come to a stable stop at 130 km/h in low light environments. BYD Hand-L also managed to brake to a stop at 130 km/h in this scenario. And under low light conditions, the X1 G7, which applies the visual solution, faced a significant test, but it has also managed to brake to a stop at 110 km/h. It has to be said that today's visual sensors are increasingly able to overcome the problem of low light. The way below mountain can come to a stop at 100 km/h. Continue testing at 110 km/h with insufficient braking force, resulting in a collision. IM does not respond to this type of scenario. Pedestrian jaywalking is a typical scenario in urban active safety. Once a collision occurs between a pedestrian and a motor vehicle, it may lead to very serious consequences. And therefore, one of the core objectives of the active safety system is to avoid or reduce collision with pedestrians. So, at what speed can each vehicle achieve a collision avoidance? First, look at the results. It can be found that the gap between each vehicle is still quite large. We divided all vehicles into 4 classes, and the vehicle of the first class can come to a stop at a speed of 85 km/h. In most scenarios, Luxy R7 can achieve perfect obstacle avoidance. Xiaomi also tied Luxy R7's score in the high difficulty test scenario, successfully braking to a stop at 85 km/h. The models in the second class can come to a complete stop within the speed range of 65 km/h to 75 km/h. And this category of the model can also handle the daily urban usage scenarios. Will complete a braking stop at 65 km/h. Will Zeekr achieved a braking stop at 75 km/h. The third class consists of vehicle models can come to a stop between 45 and 55 km/h. In areas with a high density of people flow, such as school, hospital, and commercial districts, the speed limit on surrounding road is generally 40 km/h. And the Onvo, BYD, Xpeng, and IM are all within this range. And the way Blue Mountain showed absolutely no reaction when faced with the scenario of pedestrian jaywalking. Non-motorized vehicle crossing, like pedestrian crossing, is a typical VRU scenario. However, non-motorized vehicle travel much faster than pedestrian and their movements are unpredictable, which will further compress the reaction time available to vehicle. And in this scenario, 2 vehicle models fail to pass this basic safety test when faced with the situation of non-motor vehicle crossing. And let's directly look at the results. The Onvo SCC and the Way Blue Mountain were unable to stop at 35 km/h. Although both trigger AB, they only start braking when they were about 4 meters away from the target, and the late braking time led to the collision. BYD successfully braked to a stop at a speed of 45 km/h. Although braking point was a bit late, BYD's braking force was very strong. The Luxy R7 and the Voya 3 Plus, 2 models equipped with ADAS-4, remain highly competitive and have achieved stable braking at 75 km/h. After braking to avoid a collision non-motorized vehicle, it will release the brake and proceed slowly to prevent the vehicle behind from rear-ending. X1 with the version solution also managed to brake to a stop at a speed of 55 km/h. IM LS6 also succeed at 55 km/h. Compared with Xpeng, IM started to decelerate as soon as it detected the action of the non-motorized vehicle encroaching on the lane, and the whole process is still very reassuring. Xiaomi had unstable performance at a speed of 55 km/h, failing twice but also succeed once. Xiaomi actually spotted the non-motor vehicle quite early, but the braking force was insufficient, resulting in collision. And Zeekr and Xiaomi have the same score, but their actual performance is different. Zeekr can stable brake to a stop at a speed of 45 km/h, but from the SR interface, the position of the non-motor vehicle shows obvious delay. At 55 km/h, it fails to recognize non-motorized vehicle at all. If we classify various A/B test items by difficulty level, the child darting out suddenly at night would definitely be in a top tier. This scenario simulates a high-risk solution that frequently occurs during daily commuting, where the dummy we set up will dash out from behind the obstacle vehicle. Low light and backlight pose a huge challenge for cameras, so will vehicle equipped with LiDAR perform better? And let's first look at the results. There are many factors that determine performance, and the perception is just one of them. For example, both IM and Blue Mountain, which failed to pass even the speed test in this round, are equipped with LiDAR. According to data discovery from background checks, IM brakes very early, but braking force was completely insufficient to avoid the collision. Relatively speaking, Blue Mountain has to work harder. The performance of the Huawei 8S remained very stable, and both Voya Free Plus and Luxy R7 have achieved excellent results. The Voya Free Plus has measured the maximum speed in the scenario. Not only does it have a high-speed sailing, but also the braking force each time and the distance to the target after stop are almost identical, demonstrating the sensor's keen and stable perception ability and the system's rapid decision-making ability, making it a benchmark in this project. Luxy was measured at 55 km/h, a bit slower than Voya, but the overall processing strategy of ADS is the same. When the dummy just poked its head out, it was recognized, an early warning was issued, and the speed was reduced. BYD handhelds performance in this scenario is not very stable. At a speed of 35 km/h, it can complete braking. In the first test at 45 km/h, braking is also equally stable and controllable. But in the second test at 45 km/h, it suddenly lost its judgment and showed no reaction at all. During subsequent repeated tests, there was still no braking reaction. Therefore, BYD's performance in this scenario is not very stable. The pure version Xpeng achieved a full stop at 45 km/h. AllOne came to a stop while braking at a speed of 35 km/h. The Zeekr 007 GT with the LiDAR has the same performance as the Xpeng with a primary vision system. However, after checking the back data, it was found that the braking point of the Zeekr was almost twice as late as than the Xpeng. No wonder it always feels like it's about to crash. Xiaomi can stable braking to a stop at a speed of 55 km/h. When the speed reaches 65 km/h, the sensor recognizes it's still a bit slow. When the child has already reached the middle of the lane, the SR interface only shows that the child has just appeared on the lane line. Finally, the late braking point led to a collision. After looking at the performance with pedestrians, let's look at the animals. I believe everyone has seen quite a few videos about the wild animals crossing, especially the reaction of Tesla FSD when facing such situations. So let's take a look at how Chinese cars' performance in this regard. The test results are as follows. In this scenario, all 9 vehicles were completely destroyed. The only vehicle that responded was the Zeekr 007 GT, which issued a warning and applied braking at a speed of 35 km/h. But the braking was initiated too late, starting only when it was only 2.45 meters away from the target, resulting in a collision due to insufficient distance. It can be seen that wild animal is currently a challenge, and it is recommended that major manufacturers learn from Tesla in the regard. And next, let's take a look at the non-standard objects. The first one is the most common water barriers. The scenario set up is that the water barriers are placed vertically, occupying 50% of the lane, and the test speed is 60 km/h. This setup is to simulate whether the vehicle can autonomously avoid construction barriers intruding into the lane. In this scenario, only 3 vehicles passed the test. The Accelerator-7 and the Voya 3 Plus triggered the side obstacle and collision system, gently steering to complete obstacle avoidance, and the process was very smooth. After the Zeekr version update, a new feature LGP has been introduced, which is mainly used for monitoring lateral obstacles and preventing collisions during vehicle driving. The specific method of collision prevention is the same as the Luxy and Voya, which is also to gently turn the steering wheel to avoid obstacles when about to collide with the water barriers. Other vehicle models cannot recognize the water barriers and can only be manually taken over for obstacle avoidance. Static blocks are used to test the hazard avoidance ability of the test vehicle when encountering static, non-standard targets. And let's take a look at the results of each vehicle. In this scenario, 6 cars cannot recognize the cardboard box. Surprisingly, the Luxy R7 is also on the list. We tested it many times and there was only a warning sound, but no braking at all. Similarly, the Voya 3 Plus with ADS4 can stable brake to a stop all the way up to the test maximum speed of 115 km/h. Surprisingly, the Zeekr 007 GT not only has significant progress in NZP, but also a substantial improvement in active safety features. In this scenario, it passed through at a speed of 115 km/h. Moreover, for every 10 km/h increase in speed, the braking point also advanced by 8 to 10 meters, with moderate braking force and a good driving experience. The Xiaomi Voya 7 achieved a full stop at 95 km/h, and its braking force is the smallest. Starting from the initial test speed of 35 km/h, the force at each speed is basically the same. And finally, there are accidental stepping on the accelerator and false trigger tests. In the scenario of accidentally stepping on the accelerator, the starting measurement distance is 5 meters, and after passing, the distance is then reduced, which means reducing the vehicle reaction time, and both forward and backward direction were measured, and the test target were a stationary child and a stationary cement block. The final score of the encounter with children are as follows. The Blue Mountain can only perform avoidance when accidentally stepping on the accelerator forward and encountering a child. AEB can be triggered at 3 meters, but not when closer. Luxy, Voya, Xiaomi, Xpeng, and Zeekr can all stable hold their power. It should be noted here that when the system responds to accidental accelerator pedal depression, it directly cuts off power. If the driver still does nothing, the system will still hit the child at a very low creeping speed. Only Luxy and Voya will trigger AEB again and automatically engage the P gear after cutting off power, which definitely deserves high price. Xiaomi will directly activate AEB at 5 meters, cut off power when the distance is less than 3 meters, and will also trigger AEB upon detecting an obstacle later, but will not actively engage the P gear. After cutting off power, Zeekr's AEB activation upon obstacle recognition is not very stable, and occasionally fails to trigger AEB again when it is relatively close to the target. Many people may have had the experience of the thinking they had already shifted into park when in fact the car was idling and rolling. In this situation, it is very easy to hit the child in the blind spot of version. And let's see if the night car can detect the child and come to a stop while idling. In this project, except for BYD Hand L and IMLR6, all other vehicle models can recognize children and trigger AEB to brake to the stop, only with different capabilities. Luxy, Voya, and Xiaomi demonstrate full max performance, being able to successfully braking even when approaching as close as 0.5 meter. Although the Blue Mountain collides at 5 meter, it becomes more stable as it goes closer and could even stop at 0.5 meter. Onvo, Xpeng, and Zeekr can achieve a 2-meter braking distance, but they are unable to be better when it comes to shorter distance. The entrance and exits of residential areas and basement parking lots are high-frequency area for cement blocks, most of which are just located into blind spot of driver's vision and are very inconspicuous. So, how do different cars perform when facing these common scenarios? Xiaomi Wheel 7 will trigger AB braking when the distance is between 1 to 5 meters and directly cut off power when the distance is less than 1 meter. When the Luxy R7 encounters a cement block while moving forward, AEB can only be triggered and the vehicle can only be stopped at a distance of 5 meters. However, the performance when encountering a cement block in the backward direction is excellent, with the ability to recognize and braking to a stop within the range of 0.5 meter to 5 meter. The Wheel 3 Plus can achieve 5 meter obstacle avoidance when encountering a cement block from the rear. However, it fails to recognize a cement block when approaching from the front and needs further optimization. And other vehicle models show absolutely no reaction when encountering the cement block. The last scene, testing the false trigger rate of the function. In this scenario, we simulate urban traffic, so the test speed range from 45 km/h to 65 km/h to see the optimization of each vehicle regarding false triggering of functions. During this test, the four models Luxy R7, Xiaomi, BYD, and Blue Mountain did not experience any false triggering of function throughout the entire process, and the system's recognition and decision-making accuracy for pedestrian crossing the road was maximized. BYD has done a relatively good job. It not only does not recklessly trigger AEB, but also promptly issue alarm warning for potential risks. Both the Zeekr and Xpeng experience a relatively high frequency of AEB false triggers during the test, indicating that there is still room for improvement. Both the Wheel 3 Plus and IMLS6 experience false triggering of function at a maximum test speed of 65 km/h. It is possible that the system decision-making becomes more sensitive as the speed increases. The Onvo SCC will experience false triggering of function in low-speed conditions. After testing these 10 major scenarios, it has to be said that the Huawei Qiankun X4 still performs stably, shows stable and excellent performance in all the items we tested. Zeekr and Xiaomi are the vehicles that have given us quite a surprise in this test, with the many items already able to compete with Huawei. Well, that's all for this episode, and don't forget to like and comment, and see you next time.